नमस्कार दोस्तों. So now we'll talk about partial differential equation. So what is partial differential equation? A differential equation which involves partial derivative is called partial differential equation. And I am not writing here what is order and degree of the partial differential equation. So I am talking about this. So what is order? Now what is order of the partial differential equation? Suppose I have a differential equation which contain partial derivative. So it is a partial differential equation. Then order of the highest partial derivative occur in this equation is called order of this partial differential equation. Okay, this is our order of the partial differential equation. Similarly, what is degree of the partial differential equation? Degree of the highest partial derivative occur in the equation is the degree of the partial differential equation. So this is order and degree of the partial differential equation. Now formation of partial differential equation. There are two methods of formation of partial differential equation. First is elimination of arbitrary constant and by elimination of arbitrary function. Okay, in this we will eliminate our arbitrary constant, maybe a, b, c, anything. In this we will eliminate our functions. Function may be anything, function or denoted by f1 or phi. In first method, if number of arbitrary constant is equal to number of independent variable, then the order of the partial differential equation is first, or we'll say the partial differential equation is in the first order form. If number of arbitrary constant is number of independent variable is more than number of arbitrary constant, or number of arbitrary constant is more than number of independent variable. Number of arbitrary constant is more than number of independent variable, then the partial differential equation is in the second order form, or maybe more by second order derivative. So if the number of arbitrary constant is more than independent variable, it is maybe second order or more than second order, or say higher order. So now let's taking a first problem in which we will eliminate arbitrary constant and generate a partial differential equation. So first problem is form a partial differential equation by eliminating the arbitrary constant. Z is equal to ax plus by plus a square plus b square. Now problem says that eliminate arbitrary constant and generate or form the partial differential equation. So our independent variable is z and dependent variable is x and y, and arbitrary constant is a, b. So before doing this, we assume that curl z divided by curl x is equal to p, or curl z with respect to curl y is equal to q. Why we are assuming this? Because if we assume this, then it is easier to form differential equation. Now we are doing partial derivative of z, which is independent variable with respect to x. So curl z with respect to curl x is equal to a plus it is b, which is constant, and we are derivating with respect to x, therefore this y is also constant, so it is 0 plus 0 plus 0. So curl z divided by curl x is equal to a, which is equal to p, because we assumed that curl z divided by curl x is equal to p to form partial differential equation. Similarly, curl z divided by curl y, again differentiate this independent variable, which is z, with respect to y. So this is 0, this is 0, this is 0, and this is 1, and this is b. So we get b, which is equal to q. So we find or get a is equal to p and b is equal to q. So z is equal to a. So a is p multiplied by x, px, plus b is equal to q, y, plus a is equal to p square plus q square. So this is our partial differential equation, which is formed by partial derivative. Okay, now take another example. Now again it's the same problem as previous problem. So differentiate this independent variable first with respect to x, and we know that curl z divided by curl x is equal to p. We assumed that because it is easier to form by this it is easier to form partial differential equation, and curl z with respect to y is also q, it is q. Now so it is 2z curl z divided by curl x. First we are partially differentiating with respect to x, then plus 2 will be jump and x minus a, 2 minus 1 is 1, and again differentiation of x and a. So differentiation of x is 1 minus 0, because we are differentiating with respect to x, plus b. So 2 will be jump and by minus b. So 2 minus 1 is 1, and again differentiation of y is 0 and it is 0. So 0 minus 0 is 0, and 0 multiplied by this 2 by minus b, so it is 0. So we get now 2 and 2 cancel. So z curl z with respect to curl x, sorry, this 2 will be not cancel, ये cancel नहीं होगा यहाँ पे. So it is 2 and 2, because it is plus sign. I think that it is a equal sign and it is equal to 1. So constant derivative of this one is 0. So 0. Now take this 2x minus a on right hand side, or transfer this 2x minus a on this right hand side. So it is 2z curl z divided by curl x is equal to minus 2x minus a. Now we will cancel 2. Now curl z divided by curl x is p. So z p is equal to minus x minus a. Now we get x minus a is equal to minus z p. Okay. Similarly, if we differentiate with respect to y, then we get y minus b is equal to minus qz. So y minus b is equal to minus qz, and x minus a is minus zb. So replace this x minus a and y minus b with minus zp and minus qz, because the partial derivative, when we apply partial derivative we get this x minus a is this and y minus b is this. So replace this and this by this minus qz and minus zp, then we get a partial differential equation. So x minus a is minus zp square plus y minus z is minus q z square plus z square is equal to 1. So zb square is z square p square plus q square z square plus z square is equal to 1. So it is our required partial differential equation, which is found a partial derivative. Okay. So now we are taking about little tricky problem. Okay, little difficult problem. So form partial differentiation again by arbitrary constant. So curl z with respect to curl x, which is equal to p is equal to derivative of z with respect to x. So it is y, because derivative of this x. So derivative of this x is 1. It is y plus y multiplied with this. Y is constant because we are derivating with respect to x. Now it is a function of x. Okay, so we know that d by dx of root x is 1 divided by 2 root x, and again d by dx of this x. Okay, similarly if we apply this on this, so y is constant. So derivative of a root function is 1 divided by 2 root x. So it is 1 divided by 2 root x square plus a square. Again derivative of this, which is below in this root x. Now in this root x contain two terms, x square plus a square. So derivative of this x square is 2x plus a, which is a constant, so it is 0. No, so it is not mean to write that a, so it is 2x plus b is 0. So now p is equal to y plus y. Now 2 and 2 cancel. It is x divided by x square plus a square. So p minus y, now take y and y common. So p is equal to y 1 plus x divided by x square plus a square. So this is wrong, because this is x square plus a square is not in base for this y. So p minus y is yx divided by x square plus a square. Okay, so this is our curl z divided by curl x. Now we again differentiate this independent variable with respect to y. So what we will get? So now differentiate again z with respect to y. So curl z with respect to curl y, which is equal to q. Now it is y, so it is x, because we are differentiating with respect to y. So y is 1, this is x, plus again y is 1 and this whole term is function of x, so it is a constant term because we are differentiating with respect to y. So it is x square plus a square plus 0. Okay, so now when you differentiate with respect to x and with respect to y, or partial differentiation, when you will do partial differentiation of independent variable with respect to y and with respect to x, then watch carefully these solutions. Watch carefully this curl z divided by curl y and curl z divided by curl x, because the solution is inside this uh, curl z divided by curl y and curl z divided by curl x. So how we get the solution? Replace this and this mutually, then we'll get partial differential equation. So how we'll get? If we put square root of x square plus a square on that side, then we get yx divided by p minus y. Okay, because this is q is equal to x plus square root of x square plus a square, or we will get value of x square plus a square from this, which is q minus x. Okay, or put x square square root of x square plus a square is equal to q minus x here, or put value of x square plus a square from this, which is equal to yx divided by p minus y from here in this equation, or put x square plus a square value from this to this equation. You will get partial differential equation. So it is your wish how to replace, by this or by this. So I am replacing from here, because x square plus a square is q minus x, so it can be written as q minus x is equal to, okay, now square root of x square plus a square is minus q minus x. Now replace this x square plus a square, square root of x square plus a square, not only x square plus a square. So p minus y is equal to yx divided by square root of x square plus a square is q minus x. So p minus y q minus x is equal to yx. This is our required partial differential equation, which is formed by partial derivative with respect to x and with respect to y by elimination of arbitrary constant. So now again same problem by elimination of arbitrary constant. So curl z with respect to curl x, which is equal to p. So we are differentiating with respect to x, so it is a e raised to the power y, a e raised to the power y plus, now here everything is constant because we are differentiating with respect to x, and 1 by 2 is constant, this constant, constant and constant, because no term contain any x, or x is not present in this term, in this and this, so it is constant because we are differentiating with respect to x. So our p is a e raised to the power y. Now curl z with respect to y. Now we will differentiate with respect to y, so which is equal to q. Now a and x constant, and derivative of e raised to the power y is e raised to the power of y, and again derivative of this power, which is y. So derivative of y with respect to y is 1 plus half a square is constant, e raised to the power 2y. So derivative of e raised to the power 2y is 2y, multiply again derivative of this 2y, so it is only 2, plus derivative of b is 0, so now this 2 and this 2 cancel, and this e raised to the power 2y same. So this is our q. Now please watch carefully, because I told in previous problem answer is inside this and this. Okay, so if we put p is equal to a e raised to the power y, if we get common from a e raised to the power y and a e raised to the power y from both these terms, so q is equal to a and e raised to the power y common, a and e raised to the power y common if we take, so then x plus, now it is a square and 1a is outside from this and this also, so this is a and e raised to the power 2y. So what is mean by e raised to the power 2y? If we write e raised to the power 2y multiply by e raised to the power y, so base is common, so power will be add, so e raised to the power y plus y is 2y, so 1 e raised to the power y is present, e raised to the power y is present, and we know that p is equal to a e raised to the power y, so q is equal to a e raised to the power y is p x plus sorry, so this is our required partial differential equation. When you will differentiate, then please watch carefully a partial derivative with respect to x, partial derivative with respect to y, because solution is inside this and this. If you watch carefully, then you will form partial differential equation by this and this.